Alright, so 3.7 calculus, indeterminate forms, and L'Hopital's rule. So essentially, this is for evaluating limits. I'm just gonna go over it really quickly. So it's just simply for evaluating limits. Limits as x approaches c of f of x over g of x sometimes yields 0 over 0. So for example, um, let's say the limit as x approaches 0 of, actually not 0, let's say 1, of ln x over x minus 1. This is just equal to 1 minus 1, and the ln of x is just going to be equal to 0, which is equal to 0 over 0. Interestingly, ln x is a little bit weird because you can't cancel it out. Remember that we can usually simplify limits algebraically, and to do so, we do something like limit as x approaches 2. For example, of x squared minus 4, and then x plus 2, which is simply equal to, or sorry, that would be x minus 2 on the bottom here. If you plug 2 in here, you would still get an indeterminate form, but if you simplify the top and bottom, you'll get x plus 2 over 1, which is equal to 4. So it is like kind of weird because ln x doesn't have a algebraic form, so you're not able to simplify algebraically here. So what do? Well, there's this guy named L'Hopital, and he determines, I guess, three separate and distinct. Actually, it would really be two. We have 0 over 0, infinity over infinity, and negative infinity over infinity. Which, again, that's why I said there's only two, because this one is technically just that with negative. And that could technically be negative 0. Actually, no, that can't be negative 0 over 0. Okay, so yeah, these are the two forms, or three, I guess. And also there's negative infinity over negative infinity, but again, you could just cross out the negatives. So these are the three forms where you could use L'Hopital's rule. Now, what does L'Hopital's rule state? L'Hopital's rule states that you can apply, or that the limit as x approaches a number of two functions that yield an indeterminate form can be evaluated simply by taking the derivative and plugging in that point directly. So we'll get some practice into, and I'll just say L for the limit. So for example, that one question, ln x over x minus 1 as a limit as x approaches 1 is going to be equal to, what's the derivative of ln x? It's 1 over x. We'll still keep that on the top, and here it will be just 1 because this gets canceled out, and the derivative of x is 1, and we directly plug it in to get 1. So that is the derivative here. In fact, this is so much easier than using sine x over x. Or this is so much easier than using arc lengths and trigonometry to find the limit as x approaches 0 of sine x over x. So for example, we learned that the limit as x approaches 0 of sine x over x is 1. But we can just use L'Hopital's to prove it. That would be negative or that would be not negative cosine x. Cosine x over 1, and cosine of 0 is just equal to 1. So again, really easy stuff, really beautiful stuff. You can use it anywhere. Like for example, let me think of another function. You could do x cubed sine x, limit as x approaches 0. And you can keep using it until it works. So for example, that would be cosine x, 3x squared. That would still be equal to 0 over 1. So that this, wait, yeah, sine x over cosine x, yep. So that would yield 1 over 0. So I guess you wouldn't be able to use L'Hopital's further here. Let me rephrase this one. Let's just use a first degree polynomial. So x, or I guess that would be the same. For x, you can just simply do L'Hopital's rule cosine x over 4, which is equal to 1 over 4. So pretty beautiful stuff here, and that's why you can use L'Hopital's rule. I'm trying to think of a function that you can apply the L'Hopital's rule twice, and I guess I will just use a polynomial. So actually, let's use an exponential. Let's do e to the 2x divided by x squared and limit as x approaches infinity. Let's try infinity this time. That's just infinity over infinity, so we can differentiate both sides. Let's apply the chain rule there, and let's apply the thing there, and then if we do the same thing, we still get infinity over infinity, and then we differentiate one more time to get 4e to the 2x divided by 2, cross those out, gets 2e to the 2 infinity, which is still equal to infinity. So the limit is infinity. Now, we don't learn this here, but there's something called convergence and divergence tests in calculus 2, I believe. And that's why you can't use the L'Hopital's rule for something like 1 over 0. Or 1 over infinity, because if 1 is constant and you can direct sub that in, then infinity, the only variable that's changing is infinity, and we know that infinity will simply just make this term closer and closer to 0. Likewise, if you do something like, or if we take infinity over infinity, the reason why we have to apply L'Hopital's here is because we don't know what is growing faster. If the top is growing faster, it's kind of like dominance theory. If the top is growing faster, there's infinity over infinity doesn't tell us anything. All that means is that both are going to get arbitrarily large or big, but it doesn't tell us which will be bigger at a specific time, which is why you have to apply L'Hopital's rule over and over. For the last part, I'm just going to expect you guys to understand this logically. So let's take x sine x, and let's do the limit as, actually let's do 1 over x sine x as x approaches infinity. So there are a couple more indeterminate forms, or not indeterminate products, I think that's what they're called, like infinity times 0, which one will get quicker, which one will go to 0 quicker, or which one will get to infinity quicker. So it's stuff like that. If we plug it directly here, we get infinity times 0. So we get it in this form. But we can rewrite sine over x as, well, we can rewrite this as sine x divided by x to get 0 over 0, and then we can differentiate both sides. But we already know this limit. It's just going to be equal to 1. So essentially, if it's like this, you have to find forms. You have to get it into a suitable form such that you can apply the L'Hopital's rule. I think a couple other forms that you have to watch out for is infinity, well, times 0, obviously. I forgot the other forms, but I know there's a couple more. Stuff like 1 to the power of infinity. Just things that you have to watch out for. All that means is you have to rewrite it in a different form, just so that the format is correct, so that you can apply L'Hopital's rule to it. So, interesting stuff.